I've got here a cheap fan controller off Amazon, which I'm hoping to use to modify the speed of the replacement fan that I've fitted into my IBM 5150. However, it comes with no documentation whatsoever, so I am going to investigate it and find out just how it works. Well, I've just gone to connect it up, and I've found that the beeper supplied with it has what looks to be a JST-PH 2-pin connector on it, but the connector on the circuit board for the beeper, labelled beep here, seems to be a JST-XH connector, which is a completely different pitch. The XH is a 2.54mm and the PH is a 2mm pitch. So the two just will not go together. So I'm going to have to replace the connector on this, I think, with a JST-XH connector. Okay, I've rewired the beeper with the correct kind of connector now. I've also replaced the terminal block for the power input because it uses the cheap kind with the little leaf that just gently squeezes the wire and will not hold it in. So I've replaced that with a much better one for mine. And I've done a certain amount of digging now with a few hints from fellows on stream, and I think I've got it nailed now how it all works and what the settings are. There is settings printed on the reverse here, but they're pretty meaningless. So it's taken a bit of experimentation to work out just what does what. Okay, so we've got 3 fan connectors on here. Fan 1, 2 and 3. Fan 1 is controlled by the MCU here using the temperature from the thermistor. The temperature sensitivity of the fan and the thermistor is set according to this table on the back here, for temperature ranges of 35 to 45, 40 to 55, 50 to 70 and 60 to 90 degrees C. And those are set using the dip switches TP1 and TP2. That's TP1 and TP2 here. Dip switches 2 and 3. The other 2 dip switches this end here are enable or disable the alarm for a fan stall for fans 1 or fan 2. There doesn't appear to be a fan stall alarm for fan 3, though that might also be covered by fan 2. So currently the alarm for fan 1 is turned on, so if I stop the fan, it immediately starts beeping and the LED flashes. Once you release the fan, it stops beeping, the LED stops flashing and the fan starts spinning again. The final dip switch 1, sets the lower duty cycle for the PWM output on fan 1. It can either be a minimum of 20% or 40% when turned on. At the moment it's set for 20%. An important thing to note is when you change any of these dip switch settings, they have no effect whatsoever until you disconnect the power and reconnect it again, at which point the MCU reads those switch settings and keeps them until you turn it off again. Fans 2 and 3 are manually controlled by these 2 potentiometers. If I just disconnect the alarm and move this fan across to fan 2, we can now vary the speed of the fan by turning the potentiometer. There is quite a delay between the changing the potentiometer and the change in the speed of the fan. But if you want a fan that's just set to a specific speed all the time, you can use fans 2 or 3 and the trim pots to set the speed. There are also 2 small hidden solder jumpers. These 2 little solder jumpers here change the entire operation of the board. One of them reverses the operation, which I haven't tried it, but from my understanding it changes the polarity of the duty cycle basically. So as temperature goes up, instead of the duty cycle going up, the duty cycle goes down. The other one disables these 2 potentiometers and feeds the temperature controlled PWM of fan 1 through to both the other 2 fans as well. So you have 3 fans all running with the same settings, the same speed setting. And that is pretty much the entirety of it.